Yeah. Good evening, everyone. So, again, let's start off. I hope everyone has tried the homework problem. Yeah. Anyone got the answer for this? How do we do this? Are those scams on? Mihan? Someone else is missing.
Yes, sir.
Cam on.
Yes, sir.
Maybe 60. What kind of answer is that? Exam you'll write like that only. Then they'll say maybe you qualified an IIT advance. You don't like that answer, isn't it? Everyone forgot, na? Remembered it. Question is angular velocity is function of time, right? What do you mean by is it correct? What do you mean by 60 is correct? Does it even make sense what you're asking, what you're typing? Let's see how to do. It's a good one. Told you this thing we have done before. So at any point of time, if you draw the triangle, is my voice clear or is there any disturbance?
It's clear.
Clear, no?
Yes, sir. Clear.
So if you take this thing at any point of time, if you get the velocity, if this is u, this is 30 degrees, this is u cos 30 and u sin 30. U cos 30, u sin 30. U cos 30 and u sin 30. So there. So at any point of time, the u cos 30s are responsible for shrinking the triangle, and u sin 30s are responsible for rotating the triangle. These u sin 30s are responsible for rotation. These guys are responsible for shrinking the triangle. After some time, the triangle does rotate like this. So after time t, the triangle becomes like this. What is this distance initially? What is OA initial? Centroid divides in the ratio of 2:1. So that guy would be 2/3 of height, which is A by √3. Agreed? Now, after time t, what will be this thing? After time t, let the side of the triangle be L. And this is your new one A, this is B, and this is C. This is O. OA final would be the initial distance a by root 3 minus the velocity u cos 30 into time. Does this make sense? The distance from A to O will decrease by u cos 30 u cos 30 into time, and this we are calling as L. So this is the side of the triangle as function of this should be equal to L by root 3, where L is the side of the triangle. U cos 30 will be root 3 by 2, 3u by 2 into time. This is the side of the triangle at time t. What is the area of the triangle? The area of the triangle is half base into height. Half into base into height is root 3 L by 2. Root 3 L square by 4. This is the third question. Find the area of the triangle at time t. So basically, the distance OA will decrease because of u cos 30. Please check the steps. Any doubts on this? Anyone not convinced with what I did here? Please ask. If you remember, we have written the same thing in kinematics also. The two velocities have two purposes. The u sin 30s are responsive for rotation, and the u cos 30s will decrease the distance from O to A. No matter how much you rotate, the velocity towards O will be always u cos 30 only. Sure, everyone? Any doubts on this page? So let the length of the triangle, side of the triangle be L after time t. Then O to A ka distance will become L by root 3, but which is also equal to A by root 3, initial distance minus u cos 30 into time. It would have decreased because of this u cos 30. The distance would have decreased by this factor, u cos 30t. Clear, everyone? Then still have to find omega. So what is angular velocity? So let's say at any time t, the triangle has become like this. If this is O and this is A, this is u cos 30 and this is u sin 30. Omega is given by the tangential velocity by the perpendicular distance r. So here V tangential is u sin 30 and the distance r will be OA final, which is what is OA final? A by root 3 minus u cos 30 into time. There, this is the angular velocity of the triangle as function of time t. This is angular velocity of the line OA. Angular velocity of point A with respect to O, centroid, which will be same for everyone, and this will be the omega of the triangle. After this, what is omega? D theta by dt. U sin 30 is u by 2. A by root 3. U cos 30 is u root 3 by 2t. Cross multiply. You end up with d theta is equal to u by 2a. Root 3 will come here. Minus 3u by multiply 2a. This would be 2a by root 3 minus u root 3, so that will be 3ut. Root 3u by 2a minus 3ut into dt. Integrate on both sides. 0 to theta, 0 to time. And I hope you remember the integration for this. Integral dx by ax plus b is given by 1 by a ln ax plus b. this thing will turn out to be theta is equal to root 3u minus 1 by 3u ln 2a minus 3ut. Limits will go from 0 to time. U will cancel. Minus root 3. If you substitute, that thing will be ln 2a minus 3ut. And if you put 0, you'll get ln 2a. Send minus inside, you end up with root 3 ln 2a by 2a minus 3ut. This is the angle rotated as function of time t. Just to give an idea there, if you remember the path of A, if this is the centroid and this is A, A is actually going like this. So what we have found is actually at any instant of time, you're finding this is the OA bar ka vector. This is the angle we are finding. This is theta as function of time t. The angle rotated by A as a function of time t. That is what we are finding here. That is the theta which we are talking about. This is the path of A. The same thing I can say about B and C also. They'll do symmetrical things. Please check it out. Angular velocity is V tangential by distance. In this case, V tangential is constant, but the distance is changing. And that distance will be O to A, and O to A will be this guy, initial distance minus U cos 30t. So both the velocities are playing a role in this question. I think we did everything. Yeah. Check. This is the angle rotated. Kinematics, calculus, circular motion, everything is there in this. It's a good one. This would be a good question. We did this in kinematics, but that's okay. The moment I ask something like this will be an advanced question. Find the angle rotated by the triangle, or find the angle rotated by A after time t. Or simply I can ask you, find the time taken for one revolution of the triangle. Then the limits will be theta should be 2 pi. For one revolution, theta is 2 pi. I'll get the time from there. Please look at the steps. Any calculation you're not convinced, please ask me. It's a good one. How did I get d theta by dt? Omega is d theta by dt now. Forgot. Isn't that the definition of angular velocity? Omega is rate of change of position, d theta by dt, angular position. So I just took this guy here, omega, and I integrated this d theta by dt as this. I just simplify this. Sin 30 is half, cos 30 is root 3 by 2. Please check. Everyone should try this problem on your own again. I think you guys can try this as a homework. Which one? Try hexagon. There are 6 particles chasing each other. So in this case, you try to find the angle rotated as function of time t. I will leave it to you. Idea is the same. That's what I'm saying. There's no need to do new things. You take the same thing which you have done and just extend it. But any doubts on this, please ask. All clear with this? Next one. Next one.
So can you go back for a minute? Yeah, sir, thank you.
Let's say we have a laser light here. which you're shining on the wall. This is point P. P is the laser ka spot. I'm sure you must have done this with your dog or a cat. You take a laser and put it on a wall and the cat chases it. So what you're doing is you're rotating this laser at a rate of omega, which is 0.1 radian per second. This angle theta, and this distance is 100 meters. A laser light is pointed towards a wall. And it is rotated by 0.1 radians per second. Find velocity and acceleration of point P when theta is equal to 60 degrees. Now, after some time, what will happen? The laser light would be like this, isn't it? P is here, then P is here, then P is here. So isn't the point P going straight line? Mein? Find the velocity and the acceleration of point P. Hope the question is clear. How do we do this? So you're shining a laser light onto a vertical wall at a distance of 100 meters. This laser light is rotated at a rate of 0.1 radian per second. How do we do this? Anyone didn't get the question, please ask me. Question is clear, you got a minute. Velocity 20 meter per second, 40. I think it is 40, looks right. Acceleration 1.5. Okay. Let's see. Acceleration 1 by 40. Remember one thing, first always assume variables, differentiate and then end में substitute करो. Don't put numbers first and differentiate, you'll get 0. Show you. See, whenever you get a question, right, think like what is changing here, what things are moving here. So whenever this spot is going up and down, what changes? What changes is this guy, isn't that the y coordinate? Agreed, everyone? So tan theta is y by 100. Differentiate both sides with time because you want d theta by dt. That is how you get omega. Or you want dy by dt for velocity. Tan ka differential will be x square theta d theta by dt is equal to 1 by 100 dy by dt. This guy would be x square theta omega 100 is velocity at point P. And then you got the velocity. Put theta 60, put omega 0.1, you'll get the answer. Differentiate this again. This would be 100 omega. Secant square ka differential is 2 sec theta. Sec theta differential is again sec theta tan theta. Chain rule. And then again d theta by dt. Don't forget, you'll get one more d theta by dt. This would be acceleration of point P. I hope everyone did that properly. Differential of secant square theta is 2 secant theta, and secant theta ka differential, that is secant theta tan theta, and again d theta by dt. It's a chain rule. There are theta is a variable here. So this guy AP would be 2 sec square theta tan theta, that will be again omega into 100 into omega square. I'll leave the values to you. You can put the values and check it out. But please ask me anyone confused with the differentiation there. I'll do one thing. I'll just write it here. D by 2 sec square theta is 2 sec theta. Differential of sec theta. That would be 2 secant theta, sec theta, tan theta, and again d theta by d. This is what I did. Please ask me if you're confused. Clear? Now you can actually make a better problem than this. Can I done the page? Any doubts on this? Nika, clear? Neil, Ali, got this? Arjun, Abhinav?
Yes, sir. Yes, sir.
Kartika, Udayan, got this? Great. Now, for people who want to do a little adventure, you can try this as a homework problem. What if you have a parabolic path? Y is equal to x square. You have a parabola. This is your origin. This is minus 10, 0. It started raining there. And we have a laser here. So this laser will fall on the parabola now. And this thing is rotating with omega. You can take 0.1 radian per second. Numbers will be bad. I'll do one thing. I'll just keep it as variables only. Minus d comma 0. Let this be omega only. That is point P. Find speed of point P. as function of coordinates x comma y. Or I can do something better. Wait. If this is going with speed v, constant, find omega of the laser. And that will be better. Same thing actually. Mathematically complex था ये कुछ है ही नहीं. This p is moving with constant speed v along the path. Find omega as function of the coordinates x comma y, where x and y are any points on the parabola. You want, I can give you coordinates actually. Take it as 1 comma 1, let it be x comma y. Try this as a homework. This is actually more of a maths problem than physics. Those who wanted to try, you can try this for fun. The previous one was a wall. Wall was more easy. If I just put a parabolic path, it becomes more messed up. Yeah. Going ahead. We have a circular frame, top view. This is O. This is a movable rod, which is going with V, which is constant. P is a point of intersection of the rod and the ring. So wherever the rod touches the ring, that point is called P. R is the radius. Basically, theta keeps on changing. So see, this is what happens. If you look at the diagram now, as the rod is moving, can you see? Initially P is here, then P is here, then P is here. So for a person standing on the center, doesn't it look like P is rotating? Are you getting how it is? As the rod is moving, the P is a point of intersection. Find the angular velocity of point P. So it gives you a feeling as if point P is moving on a circle. So P is not a fixed point on the rod. P is a point of intersection of the rod and the ring. So as the rod is sliding, the point P also, next moment, see now, P will come here. Next moment, P will come here. So it gives you a feeling the point P is actually rotating on a circle. Find the angular velocity of point P. Hope the question is clear, everyone. Vidyut, Rehan, question is clear. Rona? Yeah, try. Got a minute or two. Ritu, so far clear? Maulika? Hastika, clear? Aryan? Perfect. Try. You got a minute. Anyone confused with this question, please ask. Someone got disconnected. Who is this? How do we do this? You just need to always think, okay, see, you want to find omega mother, we need to find d theta by dt. So when the rod moves, see what changes. You have to get theta in terms of some variable. When you differentiate that variable, you should get velocity. Because you know only two quantities here, radius and v. So, and d theta by dt will be omega. So you have to get theta in terms of a variable. When you differentiate, you will get velocity. That is your thought process. Think for a minute, and I'll show you. Easy one. This would be like a mains one, not complex, but it's a good one. Show you v square by r is omega. What is that? See. Like I said, now you guys need to think deeply about what you're doing, right? You guys need to learn that, and that takes time. Okay, when you're learning, it takes time. But once you get used to it, right, that will be a natural instinct. You see a problem and you start seeing the things like, oh, okay, this is what I do. Think about it. Whenever this rod moves, what changes? Which distance changes? This na x, isn't it? Whenever the rod moves, what changes is the horizontal distance. Okay, question. What is cos theta? Adjacent by hypotenuse. It is x by r. Differentiate on both sides. In the previous question, the vertical distance was changing. This guy would be sine theta d theta by dt 1 by r dx by dt. So minus d theta by dt is v by r sine theta. And this is your omega. Why minus? Negative because the theta is decreasing. So minus d theta by dt will be omega. So omega is v by r sine theta. Yeah, easy. Check. So that is how your thought process should be like, okay, when the rod moves, the theta is there and this horizontal distance x is changing. R is constant. Now you can say, sir, y is also changing. Agreed. But do you know what is dy by dt? We don't know. Now see, the point is that multiple things change, but you need to understand, can I use that? You can also take sine theta. Why problem with you? That's what I'm saying. Do you know what is dy by dt? We don't know, right? We don't know dy by dt. Now it is not wrong. Sine theta is y by r, but I don't know what to do with dy by dt. So it is like that. Just because it is there doesn't mean it is useful. When I think of like this, why do you have dogs at home or cats at home? Technically speaking, they're of no use, except they look cute and they're little fun to roam around. But yeah, there's no technical use. चलो dog भी फिर भी थोड़ा ठीक लगता है. Cat, what is the use of a cat? Cat, I never found it sensible. You know what? It is like humans have domesticated dogs from last thousands of years. Cats have domesticated humans. It is the other way around. If you give some food to the dog, you know what the dog thinks? Oh, this guy must be a great god. He is giving me food and taking care of me. But when you give food to a cat, you know what it thinks? Oh shit, I must be a god, or else why will this guy give me food? cats are super egoistic. So let's see, next one. Now, today we're talking about in the medical batch, like cats and dogs. Who domesticated whom? Cats are quite smart in that way. Cats don't give a damn. The owner dies, cat just goes to some other place and eats. Dog will still there and cry and feel bad. Next one. Yeah, this is a good one. Standard question. It did come in the exam. This is point O. This is point A. We have a particle going in a circle with speed u, radius r. Particle goes in a circle with speed u. Find omega as seen by O, the center, and A. A is a point on the circumference. If you have an observer on the circumference and if you have an observer on the center, what is the omega? Omega depends on where is the observer. Huh? There are two people here. If you ask O and if you ask A, what is the omega at this instant? Find the omega. This came in bits or see, I don't remember. Their question was find the ratio of omega seen by O and omega by A. It's the ratio they asked. Try this, easy one. Venkatesh, you need to keep your cam on. Others, do adjust your cam so that I can see your face completely. I can't see some of your faces. Now, I know you guys got pretty good hairstyle, but we prefer if the faces are completely visible. So that we know in case you're eating some red velvet cake secretly, we can find out. Yeah, right, Ajay. You guys are still fine. Your seniors to eat secretly Nutella. Yesterday, I caught one guy with the big spoon in the mouth eating secretly. He thought his cam was off. We just highlighted his screen and we are watching him for a minute. And then he realized it was fun. Try. Easy one. I'll give you a minute. Get me the values, Arjun. Ratio to right, eh?
Okay.
I think you got it though. See, Aryan, dimensions are not matching. What are you talking? U square by 2 or kahan se aaya? That U square by R is acceleration. See, so when you stand at O, if this is U, this is perpendicular, this is angle theta. We know omega as O is U by R, V tangential. This is also d theta by dt. But you can't do the same thing for A. Problem is, for A, this is not 90, right? V tangential is not U. Are you getting this? V tangential is not U. And I hope you remember this angle will be theta by 2. Studied in school? So in case you have don't remember that, let's call this alpha. This also will be alpha. This will be 180 minus theta. So the total angle will be 2 alpha plus 180 minus theta should be 180. So alpha is theta by 2. So angular velocity as seen by A will be d alpha by dt. The rate of change of angle as seen by him, which would be half of d theta by dt, which is u by 2 bar. So A will think this guy is rotating at half of the speed compared to the O. you can't write u by r because this is the r and that u is not perpendicular. You have to take a perpendicular component to this and divide. You get the same answer. But that will be quite lengthy. Please check. We have done velocity. Okay, omega stuff to be done. Clear, everyone? Can I go ahead? Easy stuff. But this was a standard problem. Be careful. Something like this you can expect again in bits, CET, mains also they can expect. They are asking some dumb questions in mains nowadays. Out of 25, there are at least 7 to 8 dumb questions nowadays. That's the reason last year the student who got highest in physics is a medical student. That is because JEE students will solve maths also, no? Medical students are just solving physics and chemistry for 1.5 hours each. So they get more time. Maths, so they just mark all A and come. Or B or any one thing. They just mark one thing and come. They don't guess randomly. Next one. Angular acceleration. Alpha. This is rate of change of angular velocity. So alpha is given by d omega by dt. This can be also written as omega d omega by d theta. I hope you can see the resemblance. Acceleration A is given by dv by dt or omega v dv by dx. They look exactly same. So alpha average would be omega final minus omega initial by time. And if you plot omega versus alpha versus time graph, what does area under alpha versus time graph give you? This is a positive area.
Change in omega.
Yeah, be careful. It is not omega. It is change in omega. So area under alpha t graph, which is integral alpha dt, gives you omega final minus omega initial. Change in omega. Similarly, if you draw alpha theta graph, anyone remembers what does this give you? A is graph now. This gives you omega final square by omega initial square by 2. B square minus u square by 2s. Hope you remember, everyone.
Yes, sir.
And if alpha is constant, we can write then omega final minus omega initial is equal to alpha t. Delta theta is omega initial into time plus half alpha t square. Everything you studied in kinematics will be there. Omega final square minus omega initial square is 2 alpha delta theta. V का प्लेस में ओमेगा फाइनल, U का प्लेस में ओमेगा इनिशियल, A का प्लेस में अल्फा एंड S का प्लेस में थीटा. That's why we call this thing circular kinematics. Check it out. The graphs, the equations, mathematically speaking, it doesn't matter. Max doesn't care whether you call it omega or V. We are the ones who are calling it on omega and V. So mathematically, the results will look exactly identical. Who is getting disconnected? Right? This Palaksh, are you there? Palaksh is not there. Palaksh is getting disconnected. Okay, it's his birthday. Or good happy birthday, but why do you need to get disconnected for that? Well, that's not the reason, right? Or is he eating the cake secretly without telling us? That's the thing. Clear with this. Any doubts on this space, please ask. Clear? Next thing. Palak's happy birthday. Where is the cake? IIT में तो we used to do that only. Night 12 o'clock, right? People all come. They buy two cakes, one to eat and one to put on the other face. And eat the cake and start beating him right and left. I think he must be doing in school also, na bumps. Did that? You lift the guy and start beating him right and left. And meaning the point is to make you feel like, why am I born? Like, why did I take birth action? That's the kind of feeling they give you. So one day na, I and my roommate, right? My side ka room Arvind karke. Normally what happens that IIT mein once you reach second or third year, you get bored of hostel food. Actually, you get bored of hostel food from first year only, right? So it is almost month ending, so we didn't have money also. And Arvind is pretty rich. He used to get a pocket money of 10,000 rupees per month. This is in 2007 and 2008. This guy was a very rich guy. And I used to do part-time job. I used to get around 4,500 rupees per month salary. So I used to get it on 17th of every month. So Saturday, Sundays, I used to teach. So in that, I used to save some 3,000 rupees and 1,500 rupees used to be my pocket money. And 1,000 rupees, I used to get scholarship every month on first. उस टाइम था there's an exam called AIEEE JEE mains. If you get a rank all India below 400, you get 1,000 rupees per month scholarship for 4 years engineering. My rank was 185, so I used to get 1,000 rupees per month. So I was making decent amount of money. Arvind का एक ही concept था. Whatever money you get, you should live like a king. Either live like a king or live like a beggar. There are only two concepts. There's nothing in the middle. I tried convincing him multiple times, Arvind, let's save the money and use it throughout the month. Nah. First 1 week, full party, full finish it off. And then all used to wait for my salary for 17th. That also used to finish off by 25th. And then last week, we are like beggars, just waiting for first again. So almost, I think 29 or 30, even my cash got over. So this guy comes to my room at around 10 o'clock and says, Arun, jate na, we'll go and eat something. I said, what will you eat? I don't have any money. I said, he's like, check in your room now, you'll find something. Arvind ka room is like a dump yard. Yeah, dump yard was a dump yard. In the room, right, you have a table, bed, and you have a chair. Usko room kaise bataya? If you go to sleep, there are a bunch of clothes on the bed. The clothes will go onto the chair. When he wants to sit, the clothes from that chair will go to the bed. So the clothes are simply shifting from one place to another place. And alag hi tha. Then I said, yeah, I don't have money. He said, let's search in the room. So he went to his room. He started searching all pockets, all shirts, everything. I started searching in my room. I found 2 rupees. He found 5 rupees. Total 7 rupees mila tha. Then I said, yeah, 7 rupees se kya hoga? I said, 7 rupees, what will you go and eat? Because I think that time the minimum Frankie cost was 10 rupee and biryani ka cost was 23 rupees. That was the cost of the items. It's a subsidy. 2007-8 ka baat tha. And then 7 rupees kuch ho gaya nahi. He said, you wait, I'll come in sometime. He went. He came back after like half an hour. He brought some 42 rupees. Just a minute, guys. Someone, just a minute. Huh. So this guy comes after some time, it's 42 rupees. I said, like, yeah, Arvind, how did you bring so much money? You know what this idiot did? He went to everyone's room. He said, like, yeah, today's Arun's ka birthday. Like, sub ready hai. Just, I just need 2 rupees more to buy a cake. Cake is 80 rupees. I have 78 rupees. I just need 2 rupees more. So that's okay, only 2 rupees. So he gave 2 rupees. Like this, he begged from 22 people. He went to literally everyone's room. Today's Arun's birthday. I need 2 rupees more for the cake. Okay, only 2 rupees, take it. Today Arun's birthday, 2 rupees more. 2 rupees more, 2 rupees more. He collected 42 rupees. And around that much amount. And he comes to me and said, like, chalo, abhi jaake khate. I said, where did you get it from? I said, I used a trick. I didn't know what he did. We went, the best part, and we are going to eat, and one of our junior is there. We call him the Lord. So this Lord comes jumping. He's like, mujhe bhi chahiye. I said, like, you're bloody, we are only beggars. On top of it, you are begging us. We went to the restaurant. IIT have a restaurant till night 2 o'clock. We went around 10:30, 11 o'clock. And after all the money, exactly some 6 or 7 rupees was left over. We said, Lord, you take this money, do whatever you want. We can't spare anything more than this. So वो अलग story The Lord did something hi-fi. He started bribing people and he did something. We'll talk about this later. So सब हो गया अच्छे से खा लिया and we came back home. Came back to the room. I was sitting in the room and 12 o'clock, someone knocked the door. I came out and said, hey, Arun, happy birthday. I was like, okay. I was like, what happened here? I was thinking. And he was just waiting. Problem here, I gave you 2 rupees now. I also need a cake ka piece. Where is the cake? Getting it. Everyone was like, I gave 2 rupees, so I need to get a cake ka small slice. And within 10 minutes, there's a crowd of 12 to 15 people standing outside the door. Everyone is waiting for the cake. Where is the cake? Where is the cake? And I was like, who told you it is my birthday? I said, Arvind. I said, ask him. Then they went and they knocked this door. That guy was sleeping inside. They woke him up. I said, where is the cake? Oh, actually, kya hai na? I thought it is his birthday today. I forgot it is not today. It is some other day. So we went to restaurant and ate the food. Are yaar, they caught him and me and they started beating us so much now. I also got bumps. He also got bumps. Right? They literally started beating us almost for 5 to 10 minutes non-stop. And the best part, the Lord also came. He's like, hey, Lord, what you are doing? We said, that guy also ate food with us. They started beating him also. Yeah, it was highlight. A lot is working in some a foreign company which specializes, in all this heavy machinery and all. He's just, almost a vice president in the company. And that guy, Hyderabad mein bada company tha. That guy, we still laugh when we go like, for 6 rupees, 7 rupees, we used to fight in the room. And we are more happy there, right? For 6, 7 rupees. Now, bloody, these people earn more, but we don't have time to meet friends. Trust me, study well, it is worth it. Place, right? You will find really weird people. Those are the kind of people you want to make friends with. If you ask me, sir, IIT kyun jana hai? It is to make good friends. That is one place I have seen, no one gives a damn like you are rich, poor, kuch nahi. They'll only see your talent because everyone has worked hard to reach there. So let's see this thing. When I said birthday, I remember that only. I got to eat free food, but then again, the bumps were like 5, 6 minutes non-stop beating. I don't think it is worth. Now think about that. The Arvind is so rich, he didn't have any shame in going and begging 20 people for 2 rupees. So this guy, if you take the relation, omega and linear and angular variables. So I think I have written this, but let's put it down again. So this is theta. This here S is your arc length. R is your radius. So if you take S is equal to R theta, differentiate on both sides. So ds by dt, S is the tangential distance. That gives you V tangential into R omega. The vector form is V tangential is omega bar cross R bar. Be careful and don't write R cross omega bar. If you differentiate this again, we get A tangential is R alpha. The vector form A tangential, this is only the tangential component, is alpha bar cross R bar. So if they give you in terms of vectors R bar and omega bar, you have to do cross product. This is a relation between linear and angular variables. The reason why the cross product looks like that, think about it. If this was your velocity and this is your omega bar, this is your R bar, this is your velocity bar. So omega cross R will give you the tangential velocity. Right hand rule. Check it out. Clear? Let's see some questions on this. Now the questions will look quite similar to kinematics, what we have done. A fan rotates clockwise 240 revolutions per minute and has an angular acceleration pi by 4 radian per second square anti-clockwise. Find the total angle rotated in 50 seconds. Let's get this. You know, how is this diagram? Did you ever do this with in a house? Like, you know, your fan is there now. Let's say your fan rotates like this. Switch off the fan. I used to do this when I was a kid. Take a broomstick and used to rotate the fan in the opposite direction with the broom and then switch on the fan. Ever tried this? Never did this. You all are good people, right? To learn physics, you need to be bad sometimes. So what happens here is you can try this after the class. You take a broom and if you rotate the fan in the opposite direction, if you switch it on, first what will happen, the fan will slow down and stop, and then will rotate in the opposite direction. I hope you're getting how the scenario looks. So we have a fan which is rotating clockwise, but acceleration is anti-clockwise. So the fan slows down and rotates in the opposite direction. Find the total angle rotated in 50 seconds. Get this. Anyone not sure about the question, please ask. Venkatesh, you need to keep your cam on. Is there any problem, you can message me. But this is the second time you already switched off today. Hi, Ritu. Got something? Your cam is blank, Ritu. Yeah, better. Try, everyone. How do we do this? Now, the problem here, you know what? If you try to visualize this in a circle, it becomes quite confusing because first it will rotate like this, slows down, then it rotates in the opposite direction. So what I would recommend, let's just assume it like a 1D motion. So first of all, what is your omega initial? 240 revolutions per minute. Be careful, SI units are radians per second. One revolution is 2 pi radians. 1 minute is 60 seconds. So this guy will be 8 pi radians per second. This is your omega initial clockwise. Alpha is pi by 4 radian per second square. So this is anti-clockwise. So basically k cap. So what I would suggest you, right? Let's do it like this. 119.5, 155 pi by 2. Okay. Since mathematically omega and velocity doesn't make sense for max, so I can just do the problem like this. Assume we have a block here whose initial velocity is 8 pi and acceleration is pi by 4 backward. So how will the motion be? It will go front, stop, and come back. Isn't this question? I hope you guys remember this. And remember, what do you mean by total angle rotated? Total angle rotated is similar to distance. Means you rotate front or you rotate back, I don't care. I'll just add it up. This problem is exactly the distance ka problem. So how do we do this? So you go front, you stop for a moment, and then you come back. So at this point, your V is 0. So V square minus U square is 2AS 8 pi whole square. 2 minus pi by 4 is S. 64 pi square minus pi by 2. Pi will cancel. S will be 128 pi. So you reach a position of 128 pi. I know I'm writing pi and all, but you can write this as omega, theta, and everything. This x is equal to 0. And we can use the formula S is equal to ut plus half at square for 50 seconds. 8 pi, 50 seconds plus half minus pi by 4, 50 square. This guy would be 400 pi minus pi by 8, 2500. How much is this? 4 2s are 4 6 are 625. Yeah. And 2s will be 3s are 1 2.5. How much is this? 87.5. Okay, meaning it has only come till here. At 50 seconds, you're here. You're done. So what's the total angle rotated? I hope what I'm doing, I'm just treating the whole thing like a linear motion. Whereas in reality, this is all thing is circle going front and going back. But if you try to draw it, you won't understand in the diagram. So total angle rotated, you have gone from 128 pi plus 128 pi minus 87.5 pi. You have to treat this into two parts, this guy and this guy. How much is this? 28 and 12.5, 30.5. 158.5. I hope I'm right, but check it out. Second part, why would alpha be negative? Udayan, your acceleration is always behind, right? Right positive, left negative. S is ut plus half at square. A is behind, isn't it? Please check this thing, everyone. You can just treat the problem like 1D motion distance wala and you can solve. Just make delta theta into displacement, V as omega final and U as omega initial and A as alpha. This works because mathematically there's no difference between them. Please check. Anyone not convinced with the calculations, anything you're not sure, please ask. And I hope you remember this problem. We have done this in kinematics. One 68 क्या? 168.5. Clear everyone? Next one. Vartika, clear with this? Ritu, clear? Arjun, Niranjan, clear?
Sir, can you show the question for 1 second?
Venkatesh, all clear so far? Clear, no? Yasha? Clear? Anika,
Okay.
got this? Great. Next one. This also you have done in kinematics. Alpha is equal to minus k omega. K is constant. Initial angular velocity omega naught. Initial angular position is theta naught. Find omega and find theta as function of time t. If you remember, the question there was a is equal to minus kb. Initial velocity u, initial position x naught. Find the velocity and position as function of time t. Exact same question. We have done this in calculus. Get this, 2 minutes. Easy one, just a math problem this is. Alpha is angular acceleration, omega is angular velocity. Omega kt square by 2 near Anika. You're goofing up somewhere. Yasha, that is right, Yasha. Arjun, you're also right, but I think you just forgot that omega naught. Try, everyone get the position also. Finish off, I'll give you a minute more. In case you forgot, should definitely go back to calculus and revise the formulas once more. Especially ln ka integration and 1 by x ka integration and e power x ka integration. Right, Adrit. Keep going. Others get it. Find theta also. हाँ निका, that is right, but उसको simplify कर सकते हैं. Ln a minus ln b ln a by b. You have to do all that. Let's see. So alpha is minus k omega. This can be written as d omega by dt. D omega by omega is minus k dt. Integrate on both sides. This will be from omega not to omega and 0 to t. This would be ln omega. Limits will go from omega not to omega is equal to minus kt. This would be ln omega minus ln omega not omega by omega not. Omega is equal to omega not e power minus kt. Integrate this again. D theta by dt is equal to omega naught e power minus kt. D theta would be e power minus kt dt integral. This will be from theta naught to theta 0 to t. This will be theta minus theta naught is omega naught by minus k e power minus k dt integral 0 to t. This would be theta is equal to theta naught omega naught by k. Be careful, e power 0 is not 0, it is 1. I skipped a step here. Do check it out. I'm sending the minus inside, so it will become 1 minus e power minus kt. I think this we did, calculus में. This is a question, 12th question. Question 12, page 131, calculus. There we did in more detail with all formulas and all. Please verify that in case you are confused. There we did with a is equal to minus k. Please check. 1 by dx by x integral is ln x. E power ax integral is 1 by a e power x.
So can't you take out the e raised to minus k as a constant outside the integral?
You will take e power minus k as a constant out. What will the t do?
K is a constant, right?
So what will the t do?
Like you write it as e raised to minus k into e raised to t. Can you do that?
E power minus k into e power t. That is,
Yeah.
is that how you write?
Sorry, my bad. Yeah, sorry. I got it.
So basically on Earth, we don't have any maths like that.
Yeah, I forgot about it.
In your civilization, if there is something, please forgive this innocent humans. We don't have enough science. Clear? Next one. Happens. Sometimes you get that inspiration to create new maths, but no problem. Clear? So that's the first part of the chapter. Circular kinematics, finding theta and the relation between stuff and all. The second part of the chapter is uniform circular motion. Now listen carefully. This is important. Most of the things which you learned in school, that centrifugal force, centripetal acceleration, all that will get cleared. So you can forget what we did in school. So let's try to see this. Uniform circular motion. So consider a particle going in a circle with a constant speed u. Let's call this UCM, uniform circular motion. In uniform circular motion, the particle goes in a circle with a constant speed. So listen carefully, people. Like if you got the understanding what is happening, that circular motion ka main part you'll get it. The biggest problem is what people don't get an idea like what the hell is happening, and that's where the whole thing becomes confusing. So, okay, that is the meaning of uniform circular motion. In uniform circular motion, the particle goes in a circle with constant speed. That's it. This is the only information you have. From this information, we can conclude certain things. We can figure out certain stuff. So this, from here, we can figure out. We can say the acceleration is always perpendicular to the velocity and towards the center. How can we say this? Now see, we are not saying observation and all that. Just because of this statement, if a particle goes in a circle with constant speed, you can confirm, you can say it is toward the center. How can we say this? Let's think this way. Let's say a particle is going in a circle with speed u, and let the acceleration be like this, making an obtuse angle. So the acceleration got two components here, a cos theta and a sin theta. Can someone tell me what will happen to the speed here? In this case, what will happen? The a cos theta is opposite to u, the speed decreases. Since the acceleration component is opposite to u, speed will decrease. The second possibility, let's say it is acceleration forward, and let's say the acceleration is this way, making an acute angle. Again, this component a cos theta, in this case, it's in the same direction. Here, the speed will increase. So basically, in both these cases, the a cos theta changes the speed. Now you tell me what else is left. You can't make an acute angle, you can't make an obtuse angle. So what is the only angle possible? Perpendicular. Therefore, that component a cos theta should be 0. Therefore, theta is equal to 90 degrees. So when a particle goes in a circle with a constant speed, there is no option. It has to be perpendicular. We proved this, okay? We proved the acceleration is perpendicular. We didn't make a blind statement. This is the first part. So if a particle goes in a circle, the acceleration should be perpendicular to the velocity. Be careful here. Speed is constant, but velocity changes because direction changes. So if you have acceleration, velocity should change. Speed may not change. That's the first conclusion we got from the data. So in a uniform circular motion, if you go with a constant speed, the acceleration can't be at any other angle except perpendicular. And there should be an acceleration, or else the velocity or direction is changing. Please have a look at this page. Ask me if you're confused. Just have a once, just go through this once. Clear? Now going ahead from here. Now, let me ask you something. Earth is going around the sun. Sun is attracting the earth. Agreed? If sun is attracting the earth, why is earth not falling into the sun? You listen to the statement. If sun is attracting the earth, why is the earth not falling inside the sun? What do you guys think? See, if I pull you, you'll come towards me. So if the sun is pulling the earth, it should come towards the sun. Why are you not falling inside the sun? Any ideas? Any answers? Guess, take a guess.
The Earth exerts force opposite.
Centrifugal force is not real. It doesn't exist. There is a repulsive force. Who is repelling it? Something else is pulling us. Who is that something? God.
The gravity.
Gravity. Sun is already pulling there. Sun is only pulling inside. Who is stopping this guy? Which gravity? Repulsion force. Which repulsion force? Someone else is pulling us. Centripetal force is nothing. What do you guys think? Gravity is only centripetal force. God force. God is actually catching the earth and making us go in a circle. Or there is a tortoise on which the earth is sitting and the tortoise is going around the earth, around the sun. That's the theory of actual Aristotle. That's what people believed. The earth was being carried on a tortoise and the tortoise is running around the sun. We don't know why the tortoise is running, but let's see what is happening actually. Centrifugal doesn't exist. You studied this in school. It's a fictitious force. So let's see what is happening actually. What is the answer for that? We'll see. Take a very small time. Understand this thing. If you understood this thing intuitively, you understand what happens here. For very small time t, so we are talking about t tending to 0. Let's say this is having speed u and this is having acceleration a. So in time t, how much will you travel? You will fall down a distance of half at square. But in that same time t, I'm exaggerating the figure. These are actually very small because t is small. This will travel a horizontal distance of ut. I'm using kinematics, everyone. Because of the vertical acceleration, you will fall half at square. And because of the horizontal velocity, you will travel ut. And this distance is radius. And this guy will be r minus half at square. It's a right angle triangle. Pythagoras theorem, r square will be r minus half at square whole square plus u square t square. So r square plus 1 by 4 a square t power 4 minus a r t square plus u square t square. This guy goes off. Take out t square common. You get 1 by 4 a square t square minus a r plus u square. So we get u square minus a r plus 1 by 4 a square t square is 0. This term is 0 since the time is almost tending to 0. You end up with a is equal to u square by r. We can also write this thing as omega square r because u is equal to r omega. So what this thing tells you, right? So look at the answer for that. So the answer for that question is why Earth is not falling into the sun. The answer is the Earth is always falling into the sun. You're getting it? There is no one stopping you from falling. But this is what is happening. Every time the Earth falls, the velocity is putting you back on the circle. You're getting it? Every time the Earth falls because of the sun, the velocity is putting you back on a circle. It falls, goes back on a circle. It falls, goes back on a circle. This is happening at such a minute level, you don't even realize it. Are you getting it? There is no one balancing the Earth. Earth is not in equilibrium. When Earth is going around the sun, there is no one to balance sun ka force. Think about it. If you stop the Earth for a moment, 0 velocity, it will go straight into the sun. Are you getting the reason? So someone asked this question, who is, kind of like a wave, but happening at a minute level, so you won't even realize it. So it's like kind of there's not an equilibrium. Earth is not in equilibrium. Net force on Earth is not 0. every time it falls, the velocity will put you back on a circle. But this happens only for a particular acceleration. Only when the acceleration is u square by r, it will go exactly on the circle. Let me get back to this. Let me show you what happens. What happens if the acceleration is not equal? If the acceleration is greater than u square by r, means if you provide more acceleration than required, means what will happen? You will fall more inside, but you'll go less outside. So the particle will actually spiral in. If acceleration is less than u square by r, means if you provide acceleration less than required, you will fall in, but you'll go more outside. They're actually spiraling out. So you won't go in a circle for any acceleration. You have to provide exactly u square by r if you want to get back on the circle. You provide more than this, you provide less than this, you won't be on a circle. So understand, when something goes in a circle, you're getting it, it is not in equilibrium. No one is balancing the force. You need to have an acceleration of u square by r to go in a circle. And this acceleration has to be provided by someone. And that someone is whom we call a centripetal force. And this acceleration is called centripetal acceleration. Have a look at this. I will put that in statements. But this is what is happening in circular motion. Every time you fall inside, the velocity is putting you back on a circle. This is what is happening in the ground shell. That centrifugal force and all that is nonsense. We'll see that what is that later on, what is centrifugal force and stuff. But for now, I think whatever we learned in school, just forget about it. Try to understand at a basic level what is happening. This is what is happening in circular motion. There is a, you can derive this using, calculus. If you remember, we have done this in calculus. Another proof. We did this in differentiation. The other question, particle is going in a circle with speed u. Find the velocity and acceleration. There we proved this thing, u square by r, centripetal acceleration. This we proved using calculus. But problem is, this thing is not intuitive. You get the answer, but you feel like, what the hell is happening? On the other hand, this thing is a very intuitive method. So someone who wants to see the calculus ka proof, it's page 50 calculus. Ellipse, we can prove this, but it will be slightly more complex. So let's not get into that. But the idea is same there. Ellipse, what it is not exactly balanced. Sometimes it is a combination of these two. Sometimes you are more, sometimes you are less. So when you go in ellipse, what happens now? Sometimes you are less, so you're getting closer. Then the speed will increase, so it will become more, you'll go outside. So it's a different thing. But please have a look at this derivation. I just use calculus. We can't actually compare that with this. This is not exactly a wave nature. You're still going on a straight lines only, no? Wave nature means something else. So wave nature is not going, if you go like this, it's not called a wave. So don't worry about that. We will discuss about what is wave nature later on. It's very confusing. But let's see that in the 12th. But any doubts on this derivation, please ask. We derived the centripetal acceleration using kinematics. Most of the books you'll find the proof in calculus. Nothing wrong, but it's not intuitive. You don't really understand what the hell is happening. Clear with this? Any doubts on this? Next page. I hope this part was clear. Spiraling in, spiraling out. So if you want to go in a circle, you have to provide exact acceleration u square by r. You provide more or less, you won't go in a circle. Please check. Clear. Next thing. Why can't the orbit be circular instead of it? Let's not get into ellipse ray. That will be more complex to study. We'll not get into that. But for circle, let's try to understand that. Now see, this is the result for that. So when you take this sun and the earth, assuming it is going in a circle. So the sun attracts the earth. So whenever you think about circular motion, remember this example. Like it help you to remember, like, oh, this is what is happening. Why doesn't it fall into the sun? So the answer for this is the earth is always falling into the sun. It's not at rest. The velocity puts it back on the circle. So every time it falls, the velocity will put you back on the circle. Every time you fall, the velocity will put you back on the circle. Every time you fall, velocity will put you back on the circle. That's what is happening. So there is no one to balance the force there. Right? But this will happen only for a specific case. So it is like every time you fall half 80 square, the UTK will put you back. Every time you fall half 80 square, the UTK will put you back, and so on. And I'm not drawing it up to scale, but I hope you got it. So let me make a statement here. So see, people have this misconception, if you go in a circle, you get a force. Go wrong here. Listen to this. This is the whole crux of uniform circular motion. If a particle wants to go in a circular motion, the particle wants to move in a circle. With speed u, it needs to have an acceleration u square by r. And this has to be given by someone. Acceleration ऐसे ही नहीं आएगा. This has to be provided by some force. This force is called centripetal force. So any force which provides this acceleration is called centripetal force. So centripetal force is not a new kind of force. And the acceleration is called centripetal acceleration. So the most common misconception is this. People think because you're going in a circle, you get a force. Wrong. Because you have a force, you're going in a circle. So here, centripetal force, right? This can be anything. The example, when the earth is going around the sun, the gravitational force is the centripetal force. You're getting centripetal force alag nahi hai, gravitational force alag nahi hai. Any force which makes you go in a circle is called centripetal force. So centripetal force is nothing but like normal, tension, spring force, gravity, friction. All these are only centripetal forces. It's not a new kind of force. Example, if I have a block here, mass m. And if this whole thing goes in a circle, here tension is the centripetal force. So be careful when you say centripetal force, this is not a new force. It is just a regular forces. If it is useful to make you go in a circle, we call it centripetal force. So centripetal force can be anything. Just have a look at this statement in this page. This is the whole idea. Most people have to confuse that. They think you get a force because you're going in a circle. So just be careful with that. That means, once you shoot a bullet, there is no way the bullet can take a turn. Let me show you what I mean.
First time in your life, Wesley. You're in control.
So this guy is trying to shoot a target. There is a, sorry, vegetarians. So there's a target on the other side. You need to supposed to curve it. Poor guy, hero is not able to shoot. Then, as usual, our heroine goes there. She's like, now shoot.
Crazy.
That is bullshit. Getting it? The girl would have died. The bullet literally turned. You're getting it? Now the question here is, which force is responsible for making the bullet turn? Just now we made a statement. If you're going in a circle or if you're curving, you need to have a force. Once the bullet comes out of the gun, other than gravity acting downward, there is no force acting horizontally. There is no way the bullet can turn like that and go and hit the target behind. You can see that. I can see how the bullet literally turns. So don't try this at real life.
So it turned twice, it turned after that.
Yeah. पहले टर्न किया वापस टर्न किया अंदर. There. It doesn't work. So that's a pretty bad thing. People die. Next thing, can you guys see this thing? This is actually a camera trick. Can you see the helicopter ka blades? It feels as if they're not rotating. And if you're thinking it's a trick, na, you can see behind, look at the background. There's ships moving behind. The waves are moving. What do you think is happening?
So the frequency with which the camera is recording is the same frequency of the rotors, right? Like when they're making the whole circle.
Why? Yeah. So let's talk about one at a time. First thing, the girl should have died. It's a movie, so we saved the girl. But in real life, don't try that. Bullets, once it comes out of the gun, there's no way they will turn. Maybe because of gravity, they'll go in a parabola. But literally, the way they showed, right, it is bullshit. The bullet would have been a headshot. Okay? So number one is that. So bullets don't take a turn. Second thing, that helicopter thing which you see, right? You must have seen this, when you're riding a cycle. Ever seen this? When you're riding a cycle, the front wheel, sometimes it is going like this, then it looks like it is going like this. Observe it. It feels like the wheel is rotating front and then wheel rotating backward. This, you can actually check it out. If you can see Niranjan's screen, can you see behind his fan? Or anyone, I think we can only have Niranjan, we can see. If you look at Niranjan's screen, look at the fan behind in the video. Can you see? It looks like it's rotating one direction, then look at the other direction. That's an illusion. What is actually happening here? Niranjan, you can put it back. Thank you. So what is happening there? Human brains are pretty tricky. They always try to deja vu it since Matrix nahi hai re. So what is happening at LUC? Human vision, right? We have something called 1/16th of a second. Means if I show you photos, right, with a gap of 1/16, you can't recognize there's a photos. Ever played with the flip book? When you flip the pages very fast, what you think is like a video. So right now, what you're seeing in the screen is 24 to 40 photographs of mine playing in 1 second. So you think it's a video. Movie is nothing but, a lot of photographs being moved very fast. You think it's a video. So your life was a lie, actually. You've never seen a video in real life. What you're seeing is always photographs, which are going fast enough. Getting it? Not only that, you have never heard your voice properly. You know that? Did you ever record your voice and try to hear it? It sounds so weird. You feel like this is not me. This is not my voice. I don't sound this bad. But you same thing, you go and show it to your mom or your friends, will say, you sound like this only. You know why that happens? What do you think? The problem is when you speak, your friend will hear the voice through the air. But when you speak, you hear the voice through the air and another sound through the cheekbones. The sound reaches your eardrums through two different ways, one through the cheekbones and one through the air. And sound travels faster in the solids. So you're actually receiving two different sounds in a very small time interval. And this time interval is so small, your brain can't figure out what to listen. So it will take both the sounds, will does a remix, and that's what you hear. And your voice will look always pleasant. Ever happened to you when you're singing a song, you feel like, yeah, my voice is so good. But the guy beside you is thinking, why is this person howling like a fox? But your voice will look pretty pleasant and acha lagta hai, like, yeah, I must be singing really good. If you actually record that, what you're singing, and you try to hear it, you will cry. You'll feel like, what is this? Why am I shouting like some kind of this thing? So if you see, right, you have never heard your voice properly. You have not seen things properly. Your whole life is a lie, but yeah, that's how it is. Now, so getting back to this photograph, so what happens, right? So our vision is 1/16. You can see only with an interval of 1/16. So normally the videos are played at a rate of 24 FPS. I'm sure everyone studied this thing. 60 hertz refresh rate, 120 refresh rate. Abhi phones are 120. Or this gaming laptops, 144 hertz refresh rate.
Yes, sir.
So 144 meaning you're putting 144 photographs per second. So what is happening with your LUC? Imagine you have a rod like this, which is going in a circle. Let's say it is rotating slowly. Now understand, you can see you're seeing actually around 16 to 20 photographs per second. You're not seeing a video. If the rod is rotating, next moment, let's say the rod comes here. Now tell me, what will your brain think? The rod has gone from here to here, no? Agreed? Now let's say rod is going little fast. What will your brain think? It has gone from here to here, no? The brain will always take the shortest path. Now see, this is where things change. What if the rod is rotating little fast and if it reaches here? Now what will the brain think? You have gone this way, isn't it? That is the reason you think it is going in the opposite direction. What if I rotate little fast? You will think you're going this way. What if I rotate such that the rod exactly comes to this position? You will think the rod is not moving. Are you getting this? You can try with this your phone and your fan in the house. If you can make the frame rate equal to the fan ka rotation speed, you will think the fan is at rest. This is what happens in that vision. That is the reason we can see, the fan there is going front and back continuously. So what is this frame rate exactly? Like, someone is planning to buy a gaming laptop, you need to know. If you're playing games, right, especially high-end games like shooting games, what happens, right? Let's say you're playing game like some Counter-Strike or, this Fortnite or whatever, and you're shooting something. Think about this. When the person is running, he's running at one speed. When he shoots the bullet is going at a different speed. Agreed? So for the game graphics, the man is running with, let's say, 5 meters per second. Bullet is going with 200 meters per second or 300 meters per second. Now, if I use only 24 frames, what will happen? The man ka video will be good. But because the bullet is traveling so fast, what will you see? You will think bullet is here, then bullet has vanished. Bullet is here, bullet has vanished. Bullet has vanished. You're getting how it looks? If you put it at low frame rate, 24 frames per second, you will think the bullet in the screen, right, is like they're vanishing, and going. The visuals will be very bad. So if you put a high frame rate like 144, you can actually see the bullet is going in a proper path. So if you're not a serious gamer, right, if you're not playing very high-end games, it's okay if you buy a normal refresh rate computer. You don't need to buy a high refresh rate. So now you know what is this refresh rate they're talking about in phones and laptops. So if you're not a super gamer, it's useless. Just buy a normal one. Clear with this?
Yes, sir.
Great. So just let me show you one example, and then let's see how to do problems in the next class. So how will they frame questions on this? Pretty straightforward. This entire uniform circular motion teaches you only one concept: how to get acceleration. Let's say we have a block here, mass m, going in a circle with speed u, radius r. Step 1, draw the FBD. It just looks like laws of motion, everyone. Tension, normal reaction, mg. Step 2, define your accelerations. Now see, this is what we will write. Since it is going in a circle, it must have acceleration. Now see, we proved this, okay? All the story I told you from last 40 minutes, we proved this thing. We're not making an assumption. It must have acceleration. If you're going in a circle, there must be an acceleration. U square by r. So acceleration is u square by r. Step 3, resolve the forces along x and y axis. So tension is equal to mass into acceleration, which is mu square by r. Solve the equations. Done. The only new thing you learned in this chapter, uniform circular motion, is you have to put A is equal to u square by r. Other than that, everything else is laws of motion only. Are you clear? The 4 steps in FBD. Draw an FBD, define accelerations, write the equations, and solve. So uniform circular motion, where you will get this step called accelerations toward the center. Everyone got the example? Let's see one question and we'll wrap up with that. Can I turn the page? That's it. Circular motion, uniform circular motion gives you only one thing: acceleration. Uske baad it is just laws of motion, FBD stuff and everything. That's it. Top view. We have a rod. This is fixed. We have a mass m. We have a mass 2m. And we have a mass 3m. You're getting how it is? It is like the barbecue nation mein hota hai na, paneer ka pieces. Able to visualize? It's like that. So 3 particles, m, 2m, 3m. See, if I talk about food, people understand the question very fast. Like I said, if someone can explain quantum mechanics in terms of food, people will understand much better. There. So the length of the rods is 3L, 3L, 3L. It's a light rod. There's no gravity, neglect gravity. This whole setup is rotating with omega. Find the tension in the rods. So this rod ka tension is T3, T2, and T1. Find tension in the rod. I hope you got the question. You're catching one end of the rod. Length of the rod is 3L. There are 3 particles, m, 2m, 3m, equidistant. The whole setup is rotating with omega. Find the tension in the rod T1, T2, T3. Try for a minute or two, then I'll show you. Next class, we will see centrifugal force and that stuff. What is centrifugal force? What to do problem? We'll do more in the next class. We should be able to wrap up the chapter by next week. After that, we'll start with work power energy. So what we did in the last class, that theta and all this stuff, what we did, those are the first 6 problems were, first 3-4 problems were actually kind of unorthodox. They're not standard ones, but those are some of the most neglected problems. Try how to do this thing. Take a minute or two. Omega square. Let me help you see. Step 1, draw your FBD. Again, remember the process always. Don't try to think like every chapter is new. If you do like that, you'll get overwhelmed. Whatever you're learning is just an incremental or something here. So let's draw 3 MK FBD. The force is T3. That's it. There's only one horizontal force. Now look at this thing. Since you're going in a circle, there will be an acceleration. So say this in your mind every time. It helps a lot. This will, you'll make sure you'll not goof up any mistakes. Since you're going in a circle, you'll have acceleration omega square 3L. That's it. Newton's second law. T3 is equal to mass into acceleration. 9m omega square L. 2m. Forces T3, T2. This guy is also going in a circle. Since 2m is going in a circle, you should have acceleration. How much? Omega square 2L. That's it. Once you write the acceleration term, circular motion is over. It is just loss of motion. T2 minus T3 net force is equal to mass into acceleration. So T2, T3 is 9 and this guy is 4. So 13m omega square L. This is T1 and this is T2. Again, since you're going in a circle, you have an acceleration. This guy would be T1 minus T2 is equal to m omega square L. And T1 would be 14m omega square L. So if you think about it, after putting that acceleration, saying that statement, since you're going in a circle, there's an acceleration. Circular motion is over there. More about this, more problems and more models. We will use centrifugal force. It will be little useful. You get answers pretty good, but you lose the understanding of centrifugal force. So more about that, we'll see on Friday. So when we continue from there, we'll continue from here. So we did almost like 9 problems. Just go through them. And I hope, Friction, everyone has finished your PACE booklet. So our classes booklet, whatever you're doing, make sure to finish off your classes ka booklet. Once you're done with that, if you're done with your PACE or LN ka booklet properly, you can go to my booklet, level 3, level 4, level 5, level 6. You can try. For people who are finding your booklet little tough, you can stick to my booklet level 1 to level 4. 5 and 6 are optional, but people who want to really do some little really tough practice or something, you can go for 5 and 6. But if you can handle till 4, that should cover even advanced ka, moderate problems ka cover ho jayega up to level 4. So that should be the target. If you do up to level 4 also, that will take care of 50-55% of the score. But you want to push further than level 5, level 6. Again, don't do too many things. Just take 1 or 2 books and do them properly. Okay, so with that, we'll wrap up for the day. I hope this was clear. Any doubts, anything?